Good morning, guys. Okay, we're going to talk about 10.4 today. You guys have already seen a little bit of it, but we're just going to go over it real quick. Okay, if you see any number, I guess I should probably title this. This is 10.4, and this is basically fractional exponents and radicals. Okay, so if you have some number a to the 1/2 power, okay, that's equal to the square root of a. We kind of talked about that in class. But furthermore, we can go a little bit deeper than this. Let's say we have a to the x over y power. Okay. What that means is this is the y root of a to the x power. So something you can take away from this is if you have, or in the exponent, okay, the denominator is the root. What kind of root you're taking? So is it the second root, the third root, the fourth root? The numerator is the exponent outside the root. Okay. So here's an example of it. Okay. Example. Let's say we've got something like, I don't know, 4 to the 2/3 power. Actually, scratch that. Let's make that 8 to the 2/3 power. Okay. So denominator is the root, so this is the third root of 8. And the numerator is the exponent afterwards. So the cube root of 8 is 2 to the second power. And we get an answer of 4. And it's just like that. Okay. Next thing we're going to talk about is switching backwards. Okay. So let's say you got something like the square root of g. Okay. If there's no number over here, right here, if there's no number right there, that you can assume that it's a 2. It's a square root. Okay. So really what goes there is a 2 for a square root. And since there's no exponent, we assume there's a 1. So this is equal to g to the 1/2 power. And that's it. Yeah. Let's say you've got something along the lines of the square root of 4x. This one's really interesting. Okay? Because what we can do is we can break this up. This can turn into the square root of 4 times the square root of x. Okay. So the square root of 4 is just 2. We can't find the square root of x, so we rewrite it as x to the 1/2 power. Okay. What you were doing the whole time right here is you were converting from radical to exponential form. If you have a whole bunch of stuff underneath, sorry, this was one example. This over here is another example. But let's say you've got something like a square root, or let's go cube root of 10x squared. Okay. Since 10 and x are both underneath the square root, that means they have to go together in the parentheses. 10 and x both have to go there because the root affects both of them. And our exponent is the 2. We're taking the third root, and that would be our final answer for converting to that form. When you evaluate, we already did a problem like this already, but we'll do it again. Okay, let's say you've got something like, I don't know, you got 9 to the 3/2 power. Okay, what that means is it is the square root of 9 cubed. Okay. So square root of 9 is equal to 3. And 3 cubed is equal to 27. What if the exponent's negative? Well, the exponent's negative. If the exponent's negative, you gotta make sure you drop it. So we gotta make sure we drop it to the bottom. So this becomes 1 over 25 to the 3/2 power. Okay. 25 to the 3/2 power, that's equal to 1 over the square root of 25 cubed. The square root of 25 is just 5, so that's 1 over 5 cubed, which equals 1 over 125. Okay, it's everything from the past coming together. There we go. Okay. So there'll be times where they ask you to simplify and leave in radical form. So you always want to try to evaluate something. If they give you the square root of 4, you give an answer of 2. But other than that, I mean, you're kind of good to go. So let's just look at something like this from your homework. We're going to do one together. This is 8x to the 4th power square root, or to the 1/2. So rule says we got to distribute that exponent in, even though it's not really distributing. We'll just say it is. And this equals 8 to the 1/2 times x. 1/2 times 4 is equal to 2. So 8 to the 1/2 power, this is the square root of 8 times x squared. The square root of 8, though, we can simplify that. 8 breaks down into 4 times 2, and that breaks down into 2 and 2. So since we have a pair of 2's, they're going to move on the evolutionary tree. They're going to live a happy life together. 2 comes out of the root, but since this guy doesn't have a match, he's going to be all by himself. And then x to the squared, or x to the second power, that just stays x squared. Okay. So this could be your final answer. You could also rewrite it to put the x squared in front so you don't get confused with the square root. So we can say that this is 2x squared square root of 2. Don't forget your roots. Another one would be like if we have 4, not 4, let's use 5 to the 1/2 times 5 to the 1/3 power. Okay. The bases are the same, so that means we have to add these exponents. So this becomes 1/2 plus 1/3. And to do fractions, we have to get common denominators. Multiply 3 to both sides on the left, 2 to both sides on the right, and we end up with 3/6 plus 2/6, which equals 5/6. So that means our answer is 5 to the 5/6 power. Or in radical form, this is the 6th root of 5 to the 5th. Dunzo Manifesto. Yeah. Whole lot of your homework is going to be stuff like this. You got to convert it to radical form or to exponential form and use the stuff that we've learned already. So one more thing is, let's see, what if we have something along the lines of this? We're going to do number 30. Number 30 looks really nice. So this is, oh, actually, yeah, we'll do number 30. Number 30 is 7 to the 4/3 power divided by the 9th root of 7 to the 6th power equals 7 to the x over 3. First step we're going to do here is we're going to get, first we're going to simplify the left side. So on the left side on top, we've got 7/4. But on the bottom, we got 7. The exponent, 6, goes in the numerator. And the 9 goes in the denominator. And now that we have the common bases, we can use the one from 10.3 that says we subtract the exponents. So this is equal to 7 to the 4/3 minus 6/9 power. Actually, you can even reduce this. We can reduce this to be 7 to the 4/3 and reduce 6/9 to 2/3. Okay. So this becomes 7. 4 minus 2 is 2/3. And remember, in our original equation, this was equal to 7x over 3. So because the bases are the same, the exponents have to be the same. So 2/3 equals x over 3. Right away, you could probably say that x is 2. I mean, if you could see it. But if not, let's cross multiply just in case. 3 times 2 is equal to 6. 3 times x is equal to 3x. Divide both sides by 3, and we get 2 is equal to x. So a lot of moving these things around, a lot of dealing with fractions, that kind of stuff. You should be okay. Next week we're gonna have a whole bunch of review, a whole bunch of practice on this stuff. So don't freak out. We'll be all right. And yeah, I guess that'll be it. So how am I gonna sign you guys off?
Well, you know you make me wanna shout.